Did you know that in 4000 BC, humanity began its first construction project? For thousands of years, people have continuously strived to find ways to transform raw materials, seemingly simple things like bamboo, wood or stone, into sturdy, easy to use and highly durable materials. Let's explore the production journey of familiar products like bamboo plywood, gypsum board or plasterboard, and wood plywood in today's video. The global bamboo plywood market size is forecasted to reach $2.7 billion by 2032. At the epicenter of this manufacturing industry lies the Asia-Pacific region, especially China, India, and Vietnam. This region not only has a cheap labour source, but also possesses extensive bamboo forests. Mozo bamboo, aged 3 to 5 years, is often used to make plywood. Workers select mature bamboo stalks around 10 inches in diameter and cut them diagonally just above the first knot to preserve the root system. Afterwards, the bamboo is transported to manufacturing facilities. Here, the bamboo is cut into segments of the desired size, and then the workers remove the knots from both the inside and the outside of the stalk. From the processed bamboo segments, workers continue to split and slice them into thin strips, called veneers. In some factories, an opening machine is used to split the bamboo stalk, helping to create many uniform strips. Next, the bamboo is soaked in running water for several days to remove starch. It is boiled in hot water or soaked in a chemical solution, sometimes salt water, to remove sugar and prevent insects and mold. Afterwards, the bamboo is put into a carbonization boiler for around 40 minutes, caramelizing the remaining natural sugars. These sugars in the stalk helps to create a natural amber color without the need for dyes. After processing, the bamboo needs to be dried to achieve long-term stability and durability. Initially, the bamboo's moisture content can be up to 50%, but after the drying stage, it must be reduced to just 8 to 10%. The bamboo is placed in a large drying room or kiln at a temperature of around 122 degrees Fahrenheit. The entire process happens slowly over 2 to 3 days to ensure that the bamboo sets firmly. Once the bamboo strips are dry, they are sorted based on colour quality and shape. Then each strip is planed to ensure a smooth and uniform surface. Workers apply glue to ensure the adhesive strength of the bamboo plywood. After gluing, the veneer layers are stacked according to the principle, a horizontal grain layer alternating with a vertical grain layer. This arrangement helps the plywood become a sturdy, durable material with a good load-bearing capacity and environmental friendliness. The next product we're discussing is gypsum. Global gypsum production in 2024 is estimated to reach 26 trillion square inches. Gypsum is found in large mountain ranges deep underground. Workers use high-powered drills to drill holes tens of meters deep, then place explosives inside. When the explosives are detonated, tons of gypsum slabs are blasted from the mountainside. Giant excavators collect these rock blocks, load them onto specialized trucks, and transport them to the factory. Some factories receive and process over 100 trucks each day. Besides natural gypsum sources, there's also synthetic gypsum. This is a byproduct obtained from industrial processes, such as ash from power plants. At the factory, raw gypsum is sent for processing. First, excavators load the rock onto the conveyor's feed hopper, turning them into small granules just a few millimeters in size. This helps the drying process happen faster and more uniformly. Next, the gypsum powder is sent into a rotary kiln under temperatures from 302 to over 662 degrees Fahrenheit for many hours. Minerals undergo a chemical reaction, transforming the original gypsum powder into calcinized gypsum. This is the foundational material for creating gypsum boards. Before mass production, technicians take samples of the calcinated powder for inspection. They mix the powder with water, add starch or setting time regulators, and monitor indicators such as expansion, durability, and hardening time. Once the formula meets the standard, an automated system mixes the exact proportions. From there, the gypsum powder turns into a thick mixture called slurry, ready to form the core of the gypsum board. At this point, giant industrial paper rolls are brought onto the line. Machines flatten the paper's surface, turning it into a sturdy base layer. The gypsum slurry mixture is sprayed forcefully onto the paper, creating an even and tightly bonded layer. Next, a system of large rollers flattens and shapes the thickness, typically from 0.3 to 0.5 inches. Another layer of paper is placed on top, sandwiching the gypsum core in the middle. The edges of the board are neatly shaped, facilitating easier installation. After being shaped, the gypsum board passes through a setting conveyor, where water slowly evaporates, helping the material become hard and firm. Once the final shape is achieved, a sensor system measures the length and an automatic blade cuts it into standard sizes such as 7.8 or 9.85 feet. Immediately after, the boards are moved onto a gigantic drying chamber at temperatures from 302 to 662 degrees Fahrenheit. Over around 30 minutes, the gypsum core completely loses its remaining moisture. The result is gypsum boards with the necessary hardness and durability for construction. Finally comes the finishing stage. Machines trim off excess parts and stack the boards. Protective paper, often printed with the logo and product information, is glued to the edges, and the boards are packaged into large bundles. Forklifts move the products into the warehouse, ready to be loaded onto specialized trucks for transport to construction sites. In recent years, the trend of gypsum recycling has become increasingly popular, especially in European countries. When a structure is demolished, the gypsum board is crushed, combined with recycled paper and additives, then remanufactured into new boards. This material can be recycled up to 10 times while still retaining almost all of its original quality. Next, we'll learn about wood plywood production process. The raw materials for this production mainly come from trees like the acacia, eucalyptus or pine. When they reach harvesting age, the trees are felled by machines, delimbed, and then divided into logs. Straight, good quality logs are used for plywood production. Meanwhile, the tops and smaller branches are utilised as biomass fuel, supplying energy directly to the factory itself. After transportation to the storage yard, the logs are strictly preserved. Workers regularly spray mist or sprinkle water on them to prevent cracking and deformation due to changes in temperature and humidity. Before processing, the wood is soaked in a hot water bath or placed in a steam chamber at around 176 to 212 degrees Fahrenheit. This process can last from a few hours to an entire day. This helps the wood soften, reduces internal stress, and prevents cracking during the peeling stage. Once the necessary softness is achieved, the wood is debarked and cut into sections from 3.2 to 8.5 feet long, depending on the finished board size. The ends of the logs are cut flat and square to ensure precision for the subsequent steps. The logs are then fed into a lathe, spun at hundreds of rotations per minute. A steel blade over 9.5 feet long presses tightly against the surface, peeling off a continuous thin veneer strip, only 0.03 to 0.11 inches thick. When the logo is reduced to a small core that cannot be peeled further, the machine cuts the veneer strips into standard sheets. The remaining wood cores are not wasted but are reused to make pallets, landscaping materials, and other engineered wood products. Freshly peeled veneer sheets have a high moisture content, often exceeding 30%. To achieve durability, they are passed through a hot air drying chamber system tens of meters long. At temperatures of over 302 degrees Fahrenheit, in just 5 to 7 minutes, the veneer's moisture content drops to the ideal level of 6 to 8%. This allows the veneer to retain the necessary flexibility while maintaining mechanical strength. After drying, the veneer sheets are coated with a thin layer of glue and uniformly spread using a roller or spray system. Next, they are stacked on top of each other according to the principle that the grain of the next layer must be perpendicular to the prior. The board now has a preliminary shape but needs to be pressed to fix the structure. The pressing process consists of two phases, cold pressing and hot pressing. In the initial phase, the sheets are put into cold press for 15 to 30 minutes to stabilize the shape, eliminate air pockets, and better distribute the glue. Then they are moved to the hot pressing for 4 to 7 minutes. At this stage, the glue undergoes a chemical reaction, penetrating deep into the wood fibres, bonding the layers into a solid block. Once pressing is complete, the plywood is moved to the finishing stage. The boards are cut to standard dimensions and edges are neatly processed, as well as the surface being sanded using a multi-roller system to achieve smoothness. Following that, every single board must undergo quality inspection. Thickness, flatness and adhesion between layers. Only when they meet the standards are they packaged, stacked into large bundles and moved to the warehouse awaiting transport. From vast forests to white gypsum mountain ranges, all are contributing to the creation of foundational materials in the modern construction industry. So, in your opinion, amongst the three materials, bamboo plywood, wood plywood and gypsum board, which will leave the most sustainable direction for the construction industry in the future? Please leave your comments here. This video ends here. Thanks for watching, goodbye and see you in the next video.